Alright, we're going to get back on the Sportster motor. It's been a few weeks here. Falling way behind. Getting junk everywhere stacked on my floor as usual. So I need to get the heads going on here. So I ground the valves yesterday. Rehoned the stems. I back cut the valve. I don't know if you can see the back cut in there. That's the second angle cut on the inside to make it smooth so it flows good. So I did that on these. These are a little bit fatter so you can see them better. So anyway, that makes it run a lot better. So right now what I'm doing, I'm going to measure the valve stem, get my number, go over to my cheat sheet over here. This correlates to what the valve stem is, to what the number is on the bore mic. The bore mics are over here. Got that one, and you got this one. So I got two mics, so I don't have to change bowls anymore. Used to be able to change the ball tips here. I have standards right here that set the valve, set the gauge. So these are to the 10th of a thou. These bore, this one's for 11/32, so it's 0.3437. So these are used to be available. There's where I used to buy them, but they don't make them anymore. So anyway, that sets this at 0. I take my valve stem number here, I add in my clearance, and that gives me the number that will be on the gauge over here. So positive is this way, negative is that way. If you look at the dial, you can see how it's marked, plus minus. Like this is at -3.2 right now, just sitting here. Obviously, if you turn that, it changes. See? And that correlates to what these numbers over here would be. So this one's -24. So the intake I use 1.4 thou clearance, exhaust I use 1.9, and I don't mind being a tenth or two extra, doesn't bother me, but I don't want to be tighter. So here's some -40 numbers here where it really gets big, or small in this case, because negative is smaller, not bigger. So then you hone the guides out to match up to these numbers here, and that's what you get. So this here is an intake probably. Yeah, this is the exhaust. Okay, so right now this exhaust here, you can see how it's not quite true because it's just a raw guide. So we are negative, we're on the plus side of 3, but actually it's -7. It has to be honed out. And the exhaust numbers would be more like these 36s and 40 numbers here. See all these different ones. So row and kibble white are different sizes too. So this one here, it's over in this area. I got to hone it all the way over to this area here somewhere, which is about 3 to 4 thou. It's roughly what you got to hone out of these holes, because the guides are just raw cut finish in there, which is hard to see. There you go. There's some. See how rough the finish is inside the guide. So when we're all done, it'll be nice and smooth. All right, so that's what all these numbers mean. It's a lot of math to get them. That's why I make a cheat sheet, because I just look at it. Numbers don't change, so it's all simple. So it's all based off the valve stem size. So that's what I got to do now. Figure out the valve stem size. Everybody says they've never seen this kind of stuff done before. Yeah, it's because nobody's stupid enough to do it. It takes forever. And every valve, I make every hole different to a tenth. Who does that? I do. Oh well. Sometimes I split half tenths too. The key is all your components have to be the same temperature. Right now it's cold as hell in here, so everything's cold, including my hands. Okay, so this is 308 and about 7. So you go over to the cheat scale over here from there, and you can see exactly what it is. It looks like it's 7. There you go. So you go to the 10th scale over here again. I don't know if you're picking up any of this. It's a bad angle for me to even read it, so I got to put it over where I can see it. Where's the number at? This way here. Light sucks too. Yeah. So smaller. This one's probably 5 or 6. Where's the 5 or 6 number at? Well, that light's screwing in my eyeballs. Your light screws with me. I can't see. That one's 6. 6. 6 again. 6. This one's going to be 6. So that's 308.6 because it's 308 over here. If you don't understand what that 6 means, that's the important number. So it's 0.3086. 6 is your fourth digit, that's tenths. So you go to your intake, 3086, right there we want negative 25. That's what the dial will be able to finish on it. Usually I leave about a thou, which is 10 tenths extra for the, before I go from my coarse stone to my fine stone. Coarse sun and stone numbers are usually 50s or 60s on the coarse side, usually 50s. And then fine is going to be in the 90s, which are their finest they make. So someone asked me that on a comment list. I don't know why, unless they're buying their own stones. In which case, they should have already known that by looking in the catalog. Okay, this one is shit way over here someplace. That looks like a 5. Yeah, that one's 5. Looks like 6 over there. This one's 5 to 6. 6 there. 5 there. So this is 5 to 6. Which one did I just measure? Is that the one I just measured? Dumbass. Take the mic, starting to warm up with my hand on it. Screwing my numbers. This one's definitely smaller. That's 4. That one's 4. 4.5. Definitely not 5. 4. We're going to call this one 4. 3084. Okay, so on my gauge down here, we don't even have a 4. That's a weird number. Okay, so 4 would be 27. Minus 27. This is what, a 6? Yeah. This should be a 25. Minus 25. There you go. So one's 27, one's 25. That's what we hold them to. 2/10 of a thou difference. Actually, more like a 1/10 and a half. That one was out around a little bit. Usually people talk out around, they're talking thousands. I'm talking tenths. A little bit tighter standards. Do I need to be that tight on my tolerances? Nope. Does it make a difference? A little bit. Difference between doing it right and not doing it right. Okay, this one's at 0. 0, how about 9? Nope, not 9. That's weird, we're about 2 over there. Let's see what happened here. Getting a different number. Check your mic. Clean your mic off with a clean towel. It's called a shirt. What did I do different? Okay, we're definitely 0 way down there. And then that is all about a 1/10. We go over here. 0, there's 1. And right here it's 2. It's big right there. Then 1. We're going to call that 1. Okay, so this is 338 with a 1. 338 with a 1. That's an odd size. That would be a minus 37. If you have a difference in diameters, you gotta guess what you want to do different. You want to be bigger, smaller, or ignore it. Makes a difference on what part of the valve is, what the problem is too. Okay, this one is way... Nope. pretty much 0. 0, 0, 0. Definitely not 9. Okay, 338.338 with a 0. That'd be a minus 38. Oop. Minus 38 on the valve. See, that's on my cheat sheet right there. It's 3380 is a 38. Alright, so now these are all set. Now I need to set those for the temperature. Even though they don't move too much, from me using them, they use from temperature a lot. Okay, done with those. So things move a lot with temperature. The 11/32 should be this one. Wipe off all the goo. Somebody used it last time. Didn't clean it very good. More like the grease congealed and made it thicker. Okay, so today you can see how things moved about 1/10 of a thou. The temperature change. Once again, do people give a squat about 1/10? I do. So there you go, on 0 now. Oop, got to hold it square and straight. You got to hold this up here square and straight. You're wiggling this to make sure your number's where you want to be. I don't know if you can see where we're at, but okay, that one's set. So that one moved 1/10 of a thou, a full 10th. You know, if it was 70 degrees in here instead of 60 degrees, it would be a different number. It might change 2/10 maybe. If it was 80 degrees, it might change 3/10. You'd be surprised. Okay, what's going on here? Something ain't right. Alright, what am I doing wrong? Is this a 3/8? Shouldn't be. Something different. Now this bore mic here sucks. It doesn't work. This is for doing little small valves, 7mm stuff. I'm going to tell you, big dollar crap. It's made wrong. The center of this and the center here are not perpendicular to the shaft here. They're at like an angle like that, so it's inaccurate. Doesn't work. Piece of junk. That's a $700 tool that don't work. Okay, so what the hell I got going on here? Something is bogus. See, here's my balls down here. The 5/16 and the other one are gone. So something is wrong with this thing right now. It is too deep. Something has changed. Usually that means somebody dropped it. This is a slip joint. It changes where the pin goes through here. Usually you don't play with this stuff. Okay, readjusted it. This has a tapered plunger instead of a split ball. So this plunger opens this up different diameters, and you can move this whole thing up and down, which changes the range this works in. Somehow something happened to this gauge. Somebody dropped it. Okay, so now it's working It was over here bottomed out. Now it's not bottomed out. See 0. See, that's where we're at right now. Right there. We're right about this area, and see, it'll go further around. So when you squeeze this. So now we're in the range of use again. So somebody help me out by dropping my tool. Now, was that me, or was it somebody else who was using my tools? I don't remember dropping my tool, but you never know. Okay, it appears to be 0 each time, but I don't like the way the ball's not moving. There it goes. See, when I do this, it should move, not be steady. Okay, it's moving, it's 0, so we're 0 now. We're perpendicular up here, which is what you want. Okay, so this is set now. Don't drop it. Makes a difference. That's a lot of prep work for a few tenths, huh? Okay, put all this junk back. You always put your tools back in the right spot, you don't lose them. If you don't have a common place for them, then you have problems with your tools being lost all the time. Okay, how many different valve sizes we got? I think they're all different. Yep, every valve is different. Sometimes you got 2 sizes for everything, sometimes they're all the same. It varies. Okay, now I'll come back for those. So now we get to go over the hone over here. Looks like I was getting ready to do cylinders last time. So we have those to do too, so I guess we can flip over and do cylinders. Cylinders require different tools. So this is our caution, do not drink out of this. It's called a cool tank, that's oil. So you take your hot part when you're honing it, you stick it down in that cold ass oil over there, and then that'll cool it. And then it comes back to room temperature, and your numbers are accurate again. So usually I use those two, front and rear, for using the initial cooling, and for the final cooling I use these two over here, front and rear again, and that way these two are always colder than those two. And a few degrees makes a difference. You'd be surprised. When you work in the tenths of a thou, this stuff all matters. Okay, so we're going to flip over here to our cylinders and get set up to do those, because that's the hones in the machine right now. Alright, let me get my mics out, be right back.